We looked last time at the area of a triangle and an area of a parallelogram. Today I'd like to talk to you about the area of a trapezoid. And it's simply just following a formula. You can always, if you're under a testing circumstance, you can always look at your reference sheet. It's right on there. And this is one of those formulas that most people don't memorize, but have it handily available so they can check and recall what it is. So I just want to remind you of what a trapezoid is. A trapezoid is a polygon where there's one pair of opposite sides parallel. So I've given two examples, and the top and the bottom lines in both of those are parallel. So there's one set of parallel lines, the others can go any way they want to. So what makes it a trapezoid is having one opposite side parallel. And you find the area of the trapezoid, this is the formula, by multiplying the height times the base of one side and the base of the other side. So what that means is the height is where there's a right angle. We're going to see this in a moment. But this is like base 1, base 2. Base 1, base 2. So you add those together, multiply it by the height, and then divide by 2. I want to show you why it looks that way. Just so you have a little bit of understanding. Sometimes it's nice to know, why am I doing it that way? So, this is why it's that way. Here is a trapezoid. And here is another trapezoid. In fact, they are the identical shape. If I put these together and make one shape out of this identical trapezoid, I will have a parallelogram. You find the area of a parallelogram by multiplying the base times the height. Well, now I have two parallelograms, so I'm going to have are two trapezoids to create that. So I'm going to have to cut that in half when I eventually get my answer. And the other reason that it's a little bit different is because in this parallelogram, let's say for example, my base up here was 4 and my base down here was 6, then that means the base here, because these are the very same, is 4 and it's 6. So I'm adding those bases together to get one long continuous. If this were the parallelogram, my base would simply be 10. But when I have it as a single trapezoid, my base are not the same height or the same length. So I have to look at that and add those two together, then multiply it by the height. And because there aren't actually two, we're going to cut it in half. So that is the premise behind why the formula looks that way, because it's a parallelogram cut in half. So I'm going to cut the formula in half. So two trapezoids put together creates a parallelogram. So we'll take that parallelogram area and cut it in half. And again, that's the formula. So we're going to look at a couple. It's very easy to do. Very easy to do. We're going to look at two examples. And again, I've already put a reminder of how we solve it right up there. So let's look and solve. I know my height always comes where the right angle is. So my height is 3 feet. My base here is 4 feet. My base here is 2 feet. So I'm going to have a height of 3 feet times, pick one of these, 2 plus 4, and then I'm going to divide it by 2. So I'm going to work in the parentheses first. 2 plus 4 is 6. This means 6 times 3. That's 18 divided by 2 equals 9 feet squared. When I'm doing area, my unit is always squared. I've addressed that to some of you with some of your work. So let's look at this second example. The same thing, we're just plugging in our numbers and solving it. So I need to figure out the height. Height is where the right angle is, and that symbol shows me right angle, so that's 5 inches. So 5 inches, and one base is 8, another base is 12, and then I'm going to divide it by 2. So the first thing I do is what's in parentheses, and I get 20 times 5 divided by 2. 20 times 5 is 100 divided by 2 equals 50, and this was inches squared. Because when I'm finding area, it is a squared unit. Inch times inch, feet times feet, that squares. The foot squared or the inch squared. So that's the area of a trapezoid.